is working towards achieving some very ambitious electrification goals. And of course, electric mobility forms a very important part of that mission. But there are some challenges to overcome in order to really drive the development of the mobility sector. To understand how to overcome these challenges, I had the opportunity to speak to Per Löfberg, who's the Senior Project Manager for Elonroad. We unpack the landscape and also learn more about how innovation is playing an absolutely critical role in meeting these electrification targets. I'm Pamela Largue, and this is the Energy Transitions Podcast. Per, thank you so much for joining us today. It's really a pleasure to be speaking with you about a really important topic, which is, of course, electric mobility. So to set the scene, tell us about some of the specific challenges within the electric mobility space.
Yes. Hi, Pamela, by the way. Nice to be here. I think there are a number of challenges with electrification and electric mobility, and it's one, batteries. It's a new way of carrying energy compared to fossil fuels. You charge something up, and these batteries are expensive, and they're heavy, and they draw a lot of resources of earth raw materials. We would like to see, they are a limiting factor, of course, because we're going to need so much batteries in everything that's moving in the future as we are moving away from fossil fuels. So we want to reduce the batteries as much as we can. The other thing is that with fossil fuels, you can fill up a vehicle very quickly in a few minutes. You can't really do that with electric. Well, you can if you have mega chargers, but it's a big problem because the grids can't really handle these loads. Imagine if you have a number of heavy trucks charging with megawatt chargers at the same time, you'll basically kill the grid, and the costs associated with expanding the grid are just enormous. So I'd say those are the two major problems that we have with electrification: grid capacity, the speed of charging, and the raw materials needed for batteries.
That makes perfect sense. I mean, if you think about the potential reliance on China, for example, if we need to import batteries, and as you mentioned, the raw materials, and of course, grid congestion, that is really a conundrum because we're trying so hard to electrify everything, and yet we have to deal with this issue of grid congestion. So what are the implications if we don't tackle these challenges?
Well, I think the implications are that we're stuck with fossil fuels much longer than necessary. I think that's the big. What's the alternative? If we go with hydrogen, we're going to have to produce, I think, up to 3 times more electricity, because you lose so much when you convert it into electricity. When you make the hydrogen, and when you convert the hydrogen into electricity again. So we're going to have to produce even more electricity if we go with hydrogen, and we'll be stuck with fossil fuels, for longer than necessary, I'd say.
Yeah, that is definitely not an ideal scenario. And that's obviously why solutions like Elonroad, are coming to the fore, really innovative. And, I know that you're a scale-up, so there is still a part of the innovation journey to go. But tell us about what you're working on at the moment.
Well, right now, we're focusing very much on areas where this problem is becoming really apparent. They will become apparent in many other sectors and on public roads, etc. But there are specific areas where they are here now, and that's ports in particular. Ports and logistics centers where you have a limited grid capacity. You're going to have to electrify for all kinds of regulatory reasons, and you don't want to buy more vehicles than you need because you don't want some to sit being charged while others are working, and you don't have space to put up a lot of charging poles and cables to run over and destroy. So that's really where we are seeing very strong traction at the moment. I think we're just seeing the beginning of what is to come.
Interesting. So ports, it's your focus for now, but obviously we will touch on some of the other use cases a little bit later on. But let's drill down into the port scenario, because I'm quite interested. I mean, obviously you've got static charging, but you've also got the electric roads. How would that look in a port situation?
Well, Yeah, the electric roads, that's really how the company started, with the electric roads. And that's really the end game, also the electric roads. That's when you charge while you are driving, while you're moving. And we work with a conductive technology. You have sliding contacts simply that pull electricity, electrons up into the vehicle. In the port, you have vehicles that operate 24/7 often. You have cranes that need to go back and forth. You have terminal tractors. You have all kinds of vehicles that are in constant motion, and you have limited space, and you want to keep them operational all the time. So one of the projects that we are working with right now, we will install in, I think, October, November this year, is in Long Beach, where we will build 400 meters of electric road, where terminal tractors can drive and charge while they are pulling containers back and forth. We will also have a few static chargers close by when they are idle or waiting for something, or lifting or unloading something else. So you can use both in that setting. Otherwise, we try to separate these two technologies. But for this particular user case, we'll use the same type of onboard equipment.
So what I'm gathering is that there's quite an international appetite for this kind of solution. Which countries are really reaching out to you?
Well, this whole thing started with Sweden and Germany, that started looking at electric road systems for public roads, for long distance transport with heavy trucks. But what's happened is that the application of the technology is becoming needed outside of the public road system as well. It's France. We have a project in France where the goal is to build 2 kilometers of electric road outside of Paris, and that's a trial that we're doing on behalf of the French government, or for the French government, so that they can make a strategic decision for the future. We're doing that with a competitor that works with a different technology. We have projects in the United States. We have almost a project in Canada. We do have a project in Malta. We're about to start a project in Singapore. We are building and we are installing in Norway soon. We will be building in Finland later this year. We have built in Estonia. We have built in Sweden. And I'm sure I've forgotten a few.
Well, that's very exciting. So it's certainly an idea that was birthed in Sweden, but it's certainly not going to stay here. That's for sure.
Yes, that's for sure. Yeah, absolutely.
I want to know from you, and please feel free to go into some technical detail on this. How does this electric road work? Paint me a picture of this vehicle moving, because obviously I've seen it, because I'm sitting with you here in person. Very exciting. But our listeners would like to possibly understand a bit more about how that works.
The way it works is a bit like, Scalextrics or Lego. We build rails that are just shy of 10 meters long, that we connect one after the other. So you get like a strip in the middle of the road, in between the wheels. We mill a shallow trench in the asphalt, just 60 millimeters deep and 35 centimeters wide. Then we place the rails there, and we attach them to the asphalt with bitumen. That goes really, really quick. We can build. In Belgium we built 750 meters of electric road in 48 hours, including everything. The way it works is that you have to connect them, obviously, to a power source, a transformer that feeds the electric road with the right amperage and volt, with the right power levels, and then we have internal feeders inside. But what we do have is, like, we have top plates on the road that are made out of stainless steel or aluminium. They are 1 meter long. In between every 1 meter long segment, you have an isolator. In that isolator, you have a radio receiver. On the vehicle, you have a radio transmitter that sends an encrypted signal to that radio receiver that tells the computer in the road, here I am, give me power. Then we use something called an IGBT. It's a switch, and you turn on the power every second meter. So every second meter is plus, every second meter is minus. You have sliding contacts. You have to have at least 3, so you're always in touch with it, 1 plus and 1 minus, and then you just drive. And it keeps turning on the power under the vehicle and it keeps turning the power behind the vehicle. So the power feed sort of moves as we move the vehicle. And you can do that with modern switch technology. You can do that really fast. So you can charge up to 300 kilowatts while driving up to 150 kilometers per hour, 160 perhaps in theory. We have not been doing it that fast. The fastest we've done is about 80 kilometers per hour, because that was the setting. It was an urban setting. We couldn't drive faster. It was too short. We had to brake as well. And we pulled 280 kilowatts in 80 kilometers per hour. That's our record, so to speak. But we know for sure we can pull more and we can go faster.
That's absolutely fascinating. Before we even start talking about your innovation journey, I do have to ask, how practical is this in terms of, would I need to retrofit a vehicle? How easy would it be to do that? Tell us a bit more about that.
And then we have to sort of separate the discussion a little bit into, because we actually work with two products right now. As a startup, you can't bet on a government deciding to build an electric road systems for the whole country. That's just too much of a bet. So a couple of years ago, we decided to make, like you can call it, a very, very short version of the electric road. It's only 3.5 meters long. But there we focus only on 0 kilometers per hour as a speed, basically standing still, what you otherwise would call opportunity charging. It's similar, the way it works, but not quite, because it becomes much simpler when you stand still in that way. And we can follow the existing protocols like CCS, for example, which means that the retrofit to charge from below, without a pole, without the cable, without anything in the way, as you are loading or unloading or at the docking bay or in the port, you just have to put an energy collector under it, which has these arms that go down, and then you have to plug it in, your normal CCS inlet, and then you're good to go. If we look at the dynamic, we're going to have to work with the vehicle manufacturers, because they are not programmed built to be able to take energy in as they move forward. That they're not, you have to reprogram them. You also have to have a DC-DC converter on board, and you have to be able to sort of manage that inlet of energy as the vehicle is moving forward. So that's a little bit more complicated, but we're doing that with a couple of OEMs already, and we know we're going to work with more soon.
Whereabouts are you on this innovation journey, and what are you hoping to see for Elonroad within the next, say, 5 to 10 years? Or am I thinking too far ahead?
No, you're not. I think for now it's with the static chargers we are a TRL. We have a commercial product. TRL, I can't remember where it ends, but 9, something like that. With the electric road systems, we are a little bit below 7, 8 perhaps. We're still, to some extent, experimenting with electric road systems, but we have all the major pieces in place.
How would you describe working in this landscape? I can only imagine it's very exciting. And I mean, I've had the privilege of meeting, 1 or 2 members of your team, and really there's a lot of energy. Describe to us what it's like.
It's a very strong pull. We're running right now. I think we're not that many, and the pull we are feeling from the market, from logistics companies, even from the OEMs now, the vehicle manufacturers, it's just growing every day. And I would say the last 12, 18 months, the shift has gone from everyone being skeptical. Well, why would you want to do that? We have cables and we're going to have mega chargers. You're not going to need any of this stuff. It just seems complicated. To, oh, wait a second here. Oh, this is actually pretty clever. Oh, can we try it? Please, can we start a project? Oh, we need to try it. Please, can you come to us? So it's a bit, we're running to keep up with the interest right now.
How I understand it, though, is this solution is one of many. So it's not necessarily the silver bullet that you're saying. Yeah?
No, we're going to need all kinds of charging. I mean, the majority of charging in the future or now already will be overnight charging, low powers. That's still going to be there. It's going to be necessary. There will be mega chargers along highways for heavy trucks for sure. We have competing technologies like the inductive, where you charge via magnetic fields, and there's a couple of strong competitors in that area. the advantage with that is that it's kind of elegant. You can't really see it on the road because you have these coils. But there are some other challenges with inductive charging. For example, with your phone, if you use an inductive charger or you put in a plug, which charges fastest? The plug, and that's a conductive charging. So we'll see. I don't think it's like one technology is going to win everything. I think right now we have found a niche where we are very, very competitive, the ports and the closed loops. And then we'll see how far we make it on the public roads, and hopefully in 10 years we'll see electric road systems on roads in France and Sweden, Germany, United States. I don't know. We'll see. Singapore, Japan, perhaps.
Very exciting. I have one final question for you, Per, and that's really about what do you believe is missing in the investment or the regulatory landscape that you believe needs to change in order to foster this kind of innovation?
I think if you look at the European context, for example, I heard a presentation the other day by a British researcher, Professor Sibon in Cambridge. He pointed to the incredibly fast development in China and in India right now. Whereas the Europeans talk about what standard should we follow and what's the best technology, etc. Whereas the Chinese and particularly the Chinese, they just go bold, go fast. I don't know how you do that because we have a completely different political system in Europe and many other places. We don't want to change that too much, I feel, but we need to learn to be a bit faster and a bit bolder and to try things. Try things on scale, then we'll see what works in reality. But we have to gamble a little bit, I think, with these projects and see which one is the best, and then take some bold decisions.
I like that. Gamble a little bit and be more bold, be faster. Although it's easier said than done, perhaps, but good advice.
It is easier said than done, obviously, and money is always a limitation for these things. Investors are skeptical in the beginning because it's a different approach. We are moving away from a system which is I don't know how long we've been using oil, but it's a century and a half, perhaps. That whole system is in place, and we're building something which is totally different. You need to store the energy in a different way. You need to distribute it in a different way. You need to use it in a different way. There's going to be an enormous amount of experimentation going on the coming decades, I'd say. We're part of that, and we just want to see more actors. We want to see more competitors. We're all up against fossil fuel. We're not really up against each other.
Oh, well said. One final question for you, Per. Am I correct that yesterday you saw a video of a particularly exciting milestone for Elonroad?
It was good because we built 200 meters of electric road for a Swedish company called Kalmar Industries. They make things like they're called reach stackers and straddle carriers. They're big port machines. And we have installed the onboard equipment. We have connected the electric road systems. And yesterday we charged that huge machine from the road for the first time after working on it for, I would say, the last maybe a year, something like that. So that was cool to see that big machine moving forward, being charged.
That is very cool. Congratulations.
Thank you.
It is indeed a milestone, and I'm sure that we will follow you on your journey as you grow.
Thank you very much. One of many to come.
Indeed. Yeah. Thank you so much for joining us today, Per. It was an absolute pleasure.
Thank you, Pamela. Thank you, Enlit. Thank you, listeners, for staying with us.
For more insights, join the Enlit community.